what is reaction term? Reaction is the rate, which is K times what?
CA.
CA1, right? So it's CA1. Why do we use CA1 in the rate equation even though it's the outlet concentration that is CA1?
Because that's the stuff that's gone.
Because?
The reactor.
Because it's a CSTR. Continuous stirred tank reactor. Why is plug flow reactor better than CSTR? In what sense? What is the big advantage of a plug flow reactor versus a CSTR?
The temperature changes.
Sorry, why?
The temperature changes throughout the BFR.
Or you have various concentrations throughout the pipe.
Okay, you're saying the right thing, but so what?
So that just you're going through just one conversion for CSTR.
Yeah, but so what? Yeah?
You start at the inlet concentrations and then you slowly lower over time in the PFR, whereas in a CSTR you start at the outlet.
Okay, so what?
So if you have a rate law that's proportional to concentrations, then they'll be
Very good. Because we're looking at first order reactions, that means the reaction rate is highest for high concentrations. In CSTR, as soon as the liquid enters, you go to the lowest possible concentration. Right? So the reaction rates are really low because you're at the lowest possible concentration. As a plug flow reactor, you start at a very high rate and gradually come down. Therefore, the volume required, of course, is much lower, right? And that's why you know that splitting it into 3 CSTRs will be better than just a single CSTR, right? Okay. So anyway, KCA1, V1, and therefore CA1 is going to be CA0 divided by 1 plus K tau, where tau, of course, is V1 over Q. Now let's say that Q is same for each reactor. It makes sense.
Are we assuming this is a liquid reaction?
It's, yeah, it's just simple first order reaction. So it's K, so this is volume V1, V2, and V3. And right now we're going to assume that the rate constant is the same in each reactor, although later on we relax that assumption and assume K1, K2, K3. All right, great. So now you can clearly figure out that CA3 therefore will be CA0 divided by 1 plus K V1 over Q, 1 plus K V2 over Q, 1 plus K V3. Right? All right, so the problem we're going to solve is very simple. We're going to ask ourselves, let's say that our constraint is V1 plus V2 plus V3 is fixed at capital V. Okay? So the total volume is fixed. The question we are asking ourselves is, what should be V1, V2, V3 to maximize the conversion? Yeah, that's the question clear to everybody? Okay, so now you can see that that's our constraint. How many unknowns? 3. How many constraints?
1.
1, right? Okay, so now, of course, if you want to maximize conversion, that means what do we want to do with CA3? Minimize it. So you can try to minimize this function, but if you're a little bit smart, what do you think you will do? Very good. You say, I'm going to maximize the denominator. Right? So rather than defining this whole thing as f, you're going to say, I'm going to define my f to be 1 plus k v1 over q, 1 plus k v2 over q, 1 plus k v3 over q. That's my f. And I'm going to make my g to be v1 plus v2 plus v3 minus v. Right? So now you can see it becomes a constraint optimization where you have one constraint and of course your function f. Yeah, makes sense? Okay, I'm going to give you a few minutes to talk to your neighbors and solve this problem.
What are we trying to maximize?
We're trying to maximize conversion, which means you're also trying to maximize f. Trying to maximize f. And yeah, so the goal is to keep the total volume to be fixed and maximize the conversion. And we want to use Lagrange multiplier to solve this problem.
There's one lambda, right? One lambda?
We'll find out.
You take 3 derivatives? Wait, don't you take a fourth one because you're taking one yourself for lambda also?
No, minimize
Oh,
No. No, you want to be no. Capital B, no. Follow that approach that I told you. Your define Lagrange multiplier, define F bar, take derivatives and so on. At least I want you to define F bar. I can take it from there.
no. Maybe.
We have to put all these things here. There's a lot of people. Yeah, just make them ABC. If I define this part as B, this part as C, it just becomes BC there, and all the rest would just be AC times A.
Why are you not doing anything?
I just take pictures. I know how to do it, but I want to wear my thing. Me and my bud here. We're chatting about it.
Sorry?
We're chatting about it.
Alright, I think most of you are on the right track. So you can define F bar as F, which is 1 plus K1, B1, oh sorry, let's just say K, B1 over Q, 1 plus K, B2 over Q, 1 plus K, B3 over Q, minus lambda, B1 plus B2 plus B3, minus 3. Right?
Minus? Oh, yeah. Oh. It's plus. It's fine.
Okay.
No. No, that you had it right.
Oh,
It's
so
minus.
you are saying because you minus minus, I
She
should
minus, yeah.
Okay, you want to write it this way?
What? No, that's right.
It's all the same, it doesn't matter. You can write whichever way. Doesn't matter. They're all same. I don't remember how I wrote G.
You have to make it equal to 0.
I wrote G as B minus that, right? So,
Plus B.
well, no, I think it was fine. It's all, sorry?
Yeah.
It actually, honestly, it doesn't matter whether you put a plus here, minus, the signs don't matter.
Oh.
You could define, in fact, you could define f bar to be f minus lambda g or f plus lambda g. Usually define f minus lambda g, but you could also define it as f plus lambda g. And the constraint could be v minus v1 minus v2 minus v3 or v1 plus v2 plus v3 minus v. It's all the same thing. Okay, so df1 or so df bar dv1 equals to 0. So this will give you what? This will give you k over q times 1 plus k v2 over q times 1 plus k v3 over q, right? And then plus lambda equals to 0, right? And similarly, you can do df bar dv2 equals to 0. This will give you k over q 1 plus k v1 over q 1 plus k v3 over q plus lambda equals to 0, right? And then of course you have the third equation df bar dv3 equals to 0, and that will be k over q 1 plus k v1 over q 1 plus k v2 over q plus lambda equals to 0. By looking at these two equations, you can see lambda lambda, by equating the two lambdas, what do you see? You see v1 has to be equal to v2. Right? Yeah, because these two lambdas are equal, so this whole thing has to be equal. K over q is same, v3 term is same, so this has to be equal to that, therefore v2 must be equal to v1, right?